Hello and welcome to Mr. Linford's math course. In today's presentation, we're going to be talking again about the applications to a system of linear equations, but this time we're going to be talking about applications to systems in three variables, where we have three unknowns. In particular, in these applications, we're going to go over a variety of topics like mixture problems and what we sometimes call cost and count problems, and we're going to see some of the similarities and different methods for solving these. Now, in this first problem, we're going to talk about a mixture. And in particular, we are making a mixture of pesto. Now, if you read this problem, you're going to realize that we want to make 96 ounces of pesto. And to make pesto, we're going to include the ingredients basil, cheese, and olive oil. Now, the amount of basil that we have should be 12 ounces more than the amount of cheese. Additionally, the amount of oil should be the same as the amount of cheese. How many of each ingredient will we need to make 96 ounces of pesto? As we read through this problem, the first thing we should ask ourselves is, what do we need to find? We've got a main idea of the problem. What are we trying to solve for? That's what's important to answer right away. And really, we're trying to solve for how many ounces of each ingredient will we need. So that is our unknown, or I guess I should say those are our unknowns, because in this case we have multiple things that we're solving for. So we need to find the amount of ounces of basil, cheese, and olive oil that we need. So let's define those as our variables. We're going to say B, C, and we'll say V here. So B is the ounces of basil. C here is the ounces of cheese. And V we're going to say is the ounces of olive oil. In the past, I've had people say, well, why don't you go ahead and use O? Well, that looks like 0, so try to avoid that. So we'll use V here. So we have this situation where we've defined our unknowns, and we see that we have three unknowns, three things to solve for. So if we have three unknowns, we need three equations. If we're going to solve for each of these unknowns, we need the same amount of equations as variables. So if there's three variables, we need three equations. If there were four variables, we need four equations. If there were five variables, we need five equations, etc. So we should look in this problem and try to find three different relationships that were given for these individual ingredients. Well, let's see. One of them that I see here is that basil should be 12 more than the cheese. Okay, that's not bad. Let's say that the basil should be 12 more than cheese. Is that B plus 12 is equal to cheese? Or is it B equals 12 plus the cheese? A lot of times students get tripped up on this wording where it says should be 12 more than. They tend to get confused. They're like, more than means addition, but are we adding it to the cheese or are we adding it to the basil? Well, one thing I would always say is go ahead and diagram your sentence, right? We have basil, which is B here, and then we say should be or is. Remember, when you get to that being verb here, that's your equal sign. And then we say 12 more than the cheese. So it looks like on the left side of the equation, the left side of the equal sign is B, and on the right side is the 12, the plus, and the cheese. So it looks like this would be the correct equation. So we have one of the equations that we need. We have to find two more. Well, if we look right here, we see another relationship, this time between oil and cheese. Oil is the same amount as the amount of cheese. So that means for our variables, we have C is equal to V. C and V are both the same thing. Now, we seem to have run out of relationships, haven't we? Because we had this property for basil and cheese. We had this property for oil and cheese. What else is there? What other relationship can we see in here between the three ingredients? Well, hopefully you notice, wait a minute, we need to make 96 ounces of pesto, and that comes from these three ingredients. So, we could say that however many ounces of basil we have, plus however many ounces of cheese we have, plus however many ounces of oil we have, should add up to 96 ounces. Because the amount of ingredients we have should give us the same amount, the sum should sum together to give us the total amount that we'll end up with. So here are our three equations. This right here is our system. We want to go ahead and solve this system of equations. Now, there's a couple ways of going about doing this. What I'd like to do is first solve this using the elimination method, the techniques that we learned in previous sections for solving a system of equations in three variables. I want us to use that technique, which is essentially the elimination method, and then I want us to practice using substitution and seeing how substitution might help us out in this case. So I'm going to say pause the video for a couple minutes, give this a try, see if you can take this system and solve it in our standard elimination approach for a system of equations in three variables. Then we'll check back in and see what you get. All right, really quick, before we get into actually solving this system, I want to point a couple things out. First up, recall that this is our main system that we're working with here, our system of three equations of three variables. One of the problems that we have to tackle first before we can even get into solving this by elimination is that we need to have these equations in the same format. In particular, we should put them all in standard form. So you'll see with these two equations, I manipulated them so that way the variables were all on the same side. Okay, I moved the C over in the one equation and the V over in the other. So that way we have B and C on the same side and C and V on the same side. Now, when I rewrote these, I could write them in standard form, but you'll notice, for example, with this problem, there was no V in this equation. There was a B, there was a C, but there was no V. So that's okay. All that I did was I put a placeholder there. I put a 0V. I added a 0V in. What's 0 times V? Well, that's just nothing. That's 0. It disappears. But I put it in there just for a placeholder's sake. Same thing for the equation C minus V. There was no B in here, so I put a 0B as a placeholder. What this does is it really helps visually because now I have all of the variables lined up. It helps out visually, and it's going to help me out when it comes to actually solving this system by elimination. So what we want to do now is use this process of elimination. I've labeled all of these equations, so you can go ahead and use these labels and use these equations in the system to solve it for B, C, and V. Now let me give you a little bit of advice before we get started here. Notice that this variable has a 0, and so does this variable. When it comes to choosing which equations to work with, that's up to you. But when it comes to choosing which variables to cancel out, I would recommend working with the C's, okay? It's difficult to work with the 0 variables, like in V or B here, because if you want to cancel them out, you're going to have to multiply one of the equations by 0, and it's generally not a good idea because you might run into trivial solutions. So what I would suggest is really focusing on canceling out the C variables. Okay, go ahead, give yourself a couple minutes, take some time to work through this system, and then we will come back and check our solution. All right, well, hopefully you had some time to work through this problem. And hopefully it was pretty easy for you knowing the system, or knowing the technique for solving a system of 3 variable equations. But let's go over this process. You can see that I chose first up the equations a and b, and I canceled out the c variable. And I ended up with this equation for d, which is 2b plus v equals 108. I then chose 2 new equations, this time b and c, and canceled out the same variable c. Ended up with this equation as equation e, b minus v equaling 12. Now, I took those equations, d and e, and I combined those together using the elimination method, and I canceled out the variable v. When this was canceled out, I ended up with just 3b equaling 120, and when I solved for b, I got 40. Now, knowing that, I plugged it into e, but I could have also plugged it into d. But in this case, I plugged it into e to get 40 minus v equals 12. And then when I solved for v, I ended up with 28. I then plugged both of these solutions into one of the original ones. Well, I said, well, let's take a look at equation e right here, which actually comes from this equation. That c and v are basically the same thing. So if I know v is 28, c is also going to be 28. And there we go. We just solved the system. If we wanted to write our answer as an ordered triple, what we should do, because in this case we don't have x, y, or z, you should, with your variables already defined, like where we say what b, what c, and what b are, we can write an ordered triple in alphabetical order by variable. So we'll write an ordered triple as b, c, and v. So in this case, that would be 40, 28, and 28 again. Let me rewrite that. If you're not working with things like x, y, and z, you're working with your own variables, just put them in alphabetical order. Or you can sometimes just define how you want the ordered triple to go. But that's the idea of this. That's the technique. Now, what I want us to do is try another method for solving this system. This time, instead of doing the elimination method that we learned in previous sections for solving 3 variable systems, I want us to try using substitution. Let's take a look at our initial problem. In this problem, you'll notice that we have our 3 equations, and some of them are equations of just 2 variables, while one of them is an equation of 3 variables. What I would like us to do is to try to solve this system by performing substitution so that we end up with one equation of 1 variable. Let's see if we can generate one equation of just 1 variable. And basically then we'll be able to solve that equation for that variable. See if you can do that. Pause the video, take a couple minutes, play around with these equations, try plugging them in for each other and see what you get. Try to see if you can generate one equation of just 1 variable. And then we'll check back in and see what you get. All right, well, hopefully this was eventually able to make sense to you and you could do the substitution that we needed for this problem. You'll notice that in this system, I decided to work with the equation that had all 3 variables in it. And what I did here was I substituted the b equaling 12 plus c in for b. So instead of writing b, I wrote what it was equal to, 12 plus c. And then instead of writing v, I wrote what it was equal to, which is c. So you can see I highlighted in blue here the substitution I did for b, and in green the substitution I did for v. So now I have an equation of all the variable c. And now I'm able to actually go ahead and solve this. So when I combine the like terms, I get 3c plus 12 equaling 96. I subtract 12 from both sides and get 3c equals 84. And if I divide by 3, I get c is equal to 8. That's the idea with substitution here. And this will generally happen in mixture problems. Try to see if there is a general equation, an equation that relates all three variables together. And you can try to see if you can do some substitution there to get one equation of just one variable. Now let's keep solving this. If c is equal to 28, well, I know that v, since they're the same thing, v is also going to be equal to 28. Now let's figure out what b is. b is 12 plus c. Well, c is 28. So c of 28 plus 12 should be a 40. And there you go. We have this many ounces for each ingredient. And this matches what we had before with the 40, the 28, and the 28. So these are two techniques we can use when solving a system of linear equations in three variables. Sometimes you'll be able to use the substitution technique. Other times, you'll have to use the elimination method that you're comfortable with. Either way, we do get the correct solution of 40, 28, 28. Let's keep practicing this and see if we can alternate between these solution methods. Now in this problem, we're taking a look at the perimeter of a triangle. And we're saying that this perimeter is 5 feet. The longest side of the triangle is 20 inches more than the shortest side. And the middle side of the triangle, or I should say the medium size of the side of the triangle, is 3 times the measure of the shortest side. Find the lengths of the 3 sides of the triangle in inches. We read through the problem. Now we should ask ourselves, what are we trying to solve for here? And you would say that we are trying to find the 3 sides of the triangles in inches. Okay? So, if we're trying to find the 3 sides of the triangles, let's define our variables. They describe the triangle as having a long side, a short side, and then a medium side. So we're not dealing with an equilateral triangle here or an isosceles. All of the side lengths are different. So we'll say L, M, and S. L is the length of longest side, and again in inches, because that's what we're asked to solve for. M is the length of the, I'll call it the medium side. And S is the length of the short side. So the shortest side there. Let me write that a little neater. And we have our 3 unknowns, so that means we're going to need 3 equations. We should look to see what our 3 different relationships we're told about for these different quantities. Well, one we can see right away is that the longest side measures 20 inches more than the shortest side. Okay, let's try to diagram the sentence here. The verb measures is our equal sign. So let me write that down. That's the equal sign. And on the left of the equal sign is the longest side. So that's L. On the right of the equal sign is 20 more than the shortest side, S. Well, there you go. L is equal to 20 plus S. That is the first equation we have here. Let me clear some space. Now let's go ahead and take a look at another relationship. This one says the middle side is 3 times the measure of the shortest. So is our equal sign again. So there's the equal sign. And on the left of the equal sign is the medium side or the middle side, M. That is equal to 3 times the shortest side. So 3s. That's it. Again, we're just finding these by diagramming our sentences. We're just looking to see where the equation would be and what's to the left and what's to the right of it. Now, do we have any other relationship? Well, we were told about the 20 inches part and the 3 times the measure of the other. Do we have any other relationship here? Well, one that we know is that the perimeter of the triangle is 5 feet. Keep in mind, perimeter means what is the sum distance around the shape. So you find the perimeter by adding up all the side lengths of the triangle. So we can say that the longest side plus the medium side plus the short side is equal to 5 feet. Now, here's our system. We want to go ahead and solve this. I want us to solve it in both ways, both the elimination method and the substitution technique. Now, one thing I want us to know right from the get-go is that as we get started in this problem, there would be an issue. And that issue is right here. Notice that this represents 5 feet, while S and L and M here are all inches. So what we need to do is use the same units. So instead of feet, we should work with inches. So instead of saying 5 here, I'm going to write 60, because 5 feet and 60 inches are the same thing. I'll put that as a little note here. 5 feet equals 60 inches. And that's why we did this substitution there. We now have everything in terms of inches. Everything is in the same units. So let's take a minute and let's first solve this using the new technique of substitution, okay? Let's solve this system using the substitution method. Then we'll practice elimination. So pause the video, take a minute, do some substituting variables in for each other, and let's see if we can generate one equation of one variable. All right, well, hopefully you were able to work through this problem and get the substitution that you needed to so that you ended up with one equation of just one variable. You can see here I ended up with the equation of all the s variables, and I was able to solve that to get s is equal to 8. Now you can see how I did this substitution. I took the equation that had all 3 variables in it, and then all that I did was I substituted what L and M were in terms of S. So you can see what I plugged in for L here and what I plugged in for M here. When I combine the like terms of the S's, I got 3S plus S is 5S. Plus 20 is equal to 60. When I subtracted 20 from both sides, I got 5S is equal to 40, so S is equal to 8. And I should say here 8 inches. Now, let's go ahead and try to find the other quantities. If the shortest side is 8 inches, then the longest side is 20 more than that, so it's going to be 28 inches. And the medium side is 3 times the length of the shortest side, so that is going to be 24 inches. And there we go. We have our solutions. We can go ahead and write these as an ordered triple. I'll probably do L, M, and S, so we stay in alphabetical order. L here is the 28, M is the 24, and S is the 8. There is our ordered triple, so we have our solutions. Hopefully you're getting the hang of this. Really, it's just the technique of just doing substitution, okay? Think of it kind of like a puzzle. Think of it kind of like a puzzle where you're just trying to keep plugging one thing in for the other to ultimately get one equation of one variable. Now what I'd like us to do is take a look at the elimination method and see if we can get this system to work. Now, we have our initial system. Note that it is not in the same standard form for every equation. So what we have to do is put them in standard form. So I moved all the variables over to one side, and then I rewrote them with placeholders in place. So I have now equations A, B, and C. What we need to do is solve this using the elimination method. Pause the video, give yourself a little practice, and then we'll come back in a minute and see what we've got for our solution now. All right, well, hopefully you were able to work through this solution, and hopefully you caught that the system did need to be changed, okay? In the previous, before we solved this, I had 5 written, but remember, we needed to convert that into inches. If you left it as just 5, you would have gotten a negative number for a side length, and we need to realize that, oh, that would obviously be a mistake. So we need everything in the same units, so the 5 feet should have been converted into 60 inches. So with that said, we went through and I started by taking A and B, and I canceled out the S variable here to get equation D. Then I took A and C, and this time I canceled out the same S variable, but to do that I had to multiply this whole equation by 3, and I got the E equation. Then I took D and E, and I decided to cancel out the M's, but to do that, I had to first multiply the top equation by a negative 4. So I ended up with L equaling 28. I plugged that back into the D equation to get M equaling 24. And I plugged both of those into equation A to get S is equal to 8. The same solutions as before. Let's take a look at another geometry example. This time, again, we're dealing with a triangle, but this time we have information about angle size. So the smallest angle measures 10 degrees more than half the measure of the largest angle. And the middle angle, or the medium angle we should say, measures 12 degrees more than the measure of the smallest angle. Find the measure of each angle to this triangle. So, what are we trying to find here? The measure of each angle. So, I'm going to use the variables L, M, and S again. S standing for the large, or I guess I should say, the degree of the large angle. M will be the degree of the medium angle, and S will be the degree of the small angle. And again, because it indicates here we have a small, a medium, and a large. This isn't an isosceles triangle. This isn't a triangle with all congruent, an equilateral triangle with like all congruent angle measures. We have all different sized angles here. So one is larger than all of them, one's smaller than all of them, and one is in the middle. So let's go ahead and find their measure. And remember, measure for angles is in degrees. So let's see what 3 relationships we have here. Well, in the very first sentence, the smallest measures 10 degrees more than 1/2 the measure of the largest angle. The smallest angle measures 10 degrees more than 1/2 the measure of the largest. That's a lot of wording, isn't it? Well, that's fine. Diagram the sentence. Where is our verb here? The smallest angle measures. So that right there is our equal sign. So what's to the left of the equal sign? The smallest angle, S. So we have S is equal to, and then everything else is on the right side. We have 10 degrees more than means addition, so 10 plus half the measure of the largest angle. Well, that's L, and half is just a half. So we should have 10 plus 1/2 L. And that's it. We have 10 more than, so that's 10 plus, and then we have 1/2 the measure of the longest, so that's 1/2 L. Let's take a look at the next relationship that we see here. This says the middle angle measures 12 degrees more than the measure of the smallest angle. Again, let's diagram. The being verb here is measures. So the middle angle M equals 12 degrees more than the smallest angle. Again, we're just using our knowledge of diagramming sentences to help us write these equations. Oh, but here's a problem. We only have 2 equations. We need 3. You have to have 3 equations to solve for the 3 variables. So what else can we do? We ran out of descriptions. Those were the only descriptions here. Well, hopefully you're saying to yourself, wait a minute. It's not written, but there is a third relationship here. We know that this is a triangle, right? It's a triangle. And what do we know about the angle measures of triangles? Well, hopefully you're saying to yourself that all of these angle measures should add up to 180 degrees. That's the last relationship we have here, because you're not told it, but it's something that they kind of expected you to know and something they expected you to remember. So knowing that, we can come up with our third equation, and it's the one that has all 3 variables in it. So let's do some substitution here. I'm going to underline this equation in blue and this equation in green. And let's start doing some substitution here. Well, I don't have anything to sub L in for, so I'm going to leave L plus M. We said that's 12 plus S, so let's do that. 12 plus S, that's what we sub in for M here. And then let's add on what S is equal to. And that is going to be in blue, 10 plus 1/2 L. And that is equal to 180. All right, we can go and combine like terms and, oh, wait a minute. We have L's and we have S's. So we didn't get a single equation of 1 variable. We now have an equation of 2 variables. We can't solve this. Well, let's see what we can do. Let's at least try to combine some of the like terms here. So 1L and 1/2 L is 1.5 or 3/2. I'll write it as 3/2. 3 over 2L plus 1S plus 12 plus 10 is 22, equaling 180. All right, problem. We have we have an L and we have an S here. What can we do? Should we generate another equation? Should we, try to combine it with another one to start canceling things out? Well, not to panic. Don't you know what S is equal to? It's equal to 10 plus 1/2 L. So why don't we just substitute it in again? A lot of times people are worried about doing that. They, do a substitution once and then they don't think they can substitute again. Of course you can. So let's see what we have here. 3/2 L plus, we know S is, let me write this in blue, 10 plus 1/2 L. And then we have to add on the 22 equaling 180. And there you go. Now everything is in the same variable. This is where people get really tripped up. People don't think that they can do a substitution twice. Of course you can. Here's an example of what that meant. You could have taken what this S was equal to and substituted it in for the S here. Then you could have subbed that in for the M here. So you are definitely allowed to substitute as many times as you need, because You know what the variable is equal to. And you can substitute those variables in for each other. Easy as that, because they're equal to each other. You're allowed to do that. All right, let's go ahead and combine these like terms. 3 halves plus 1 half is 4 halves, so that's 2. So we end up with 2L plus 10 plus 22 is 32 is equal to 180. If we isolate the L's here, we get 2L is equal to 180 minus 32 is 148. And if we divide that by 2, we get L is equal to 74. So that's the measure of the large angle, 74 degrees. The small angle then would be half of that. So 74 times a half is 37, and 10 more is 47. And the measure of the medium angle would be the 47, the small angle, plus 12. So that would be a 59. So we have 47 degrees, 59 degrees, and 74 degrees. And that is those are our angle measures. That's our solution. Hopefully this idea of the substitution method is making sense to you and you're feeling comfortable with it. But hopefully you're also feeling comfortable working with the elimination method and comfortable applying that technique here to solving a system of equations in 3 variables. Let me know if you have any questions or comments. Feel free to send me an email at klinford, that's KLINFORD, at wccnet.edu. Let me know what you thought of the video, if you have any questions or comments, and until next time, take care.